Here I am explaining electron energy levels in atom. For that I am taking the smallest atom, the hydrogen atom. So for the hydrogen atom, you know that hydrogen atom has only one electron. So electron in the lowest energy level, you know that n equal to 1, that is the first orbit, n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6. It goes like that. So these are the different energy levels. These are the different energy levels. So in the first energy levels, the energy value is minus 2.18 multiplied by 10 to the power minus 18 joule. And second energy level minus 0.54 multiplied by 10 to the power minus 18 joule. And third, fourth, fifth, sixth, it continues. Here the y-axis is taken as potential energy. It is measured in joule. So you can see that when the energy levels, the values are negative. That shows what? When the electrons comes near to the nucleus, the potential energy decreases. The potential energy decreases. Or when the electrons are near to the nucleus, they are bound to the nucleus. They are bound to the nucleus. That means there will be an attractive force between the electron and the nucleus. So minus sign indicates what? Minus sign indicates the potential energy decreases when the electron comes towards the nucleus. When it moves away from the nucleus, you can see this, the minus value decreases. That means what? The electrons are moving away from the nucleus. So the force of attraction between the electron and the nucleus decreasing. So when that force of attraction decreases, the value is becoming more. Okay, here the first value is minus 2.18, second is minus 0.54. So the value is increasing. When it comes towards the nucleus, the potential energy decreases. When it moves away from the nucleus, the potential energy increases. So the minus value decreasing, that shows the electrons, it is moving away from the nucleus. So minus value indicates what? The electrons are bound to the nucleus. That means there will be a force of attraction between the electron and the nucleus. So did you see that the last value, it is written as 0 joule? That means what? The electron that has no force of attraction with the nucleus. That means the electrons are free from the nucleus. It is free from the force of attraction of the nucleus. So 0 joule indicates what? 0 joule indicates there is no force of attraction between the electron and the nucleus. It is completely free from the nuclear force of attraction. So when an electron comes towards the lower energy level, it can come towards the lower energy level or it can move to the higher energy level. So when the electron moves from the lower energy level to the higher energy level, that means excitation. So when the electrons are excited, means what? It is moving from the lower energy level to higher energy level. When it deexcitation means what? When the electron comes from the higher energy level to lower energy level, that is known as deexcitation. Excitation, it is from lower to higher energy level. Deexcitation means it is from the higher energy level to the lower energy level. When the electrons moves from the higher energy level to the lower energy level, how much it is absorbed when it is moved from lower energy level to higher energy level. So how much it is absorbed, that much amount of energy is released by the electron. And that type of energies, that amount of energy you can see as radiation. So there will be excitation and deexcitation. Excitation means lower energy level to higher energy level. Deexcitation means higher energy level to lower energy level. So when we give energy to the atom, the electrons in the atom will excite. So when the excited state is, it is not normal. It is not stable. it is not stable, it is unstable. It is not stable, it is unstable. So when the electron reaches in the higher energy levels, they are not stable, and after a time it will come back to the lower energy level by releasing energy. That is known as deexcitation. So during deexcitation, the electrons will emit radiations. Okay, so that depends upon what the difference in the energy levels. If there is more difference in the energy level, there will be more frequency of light emitting. If less is the difference in the energy level, it will release out less amount of energy. So this is explained for hydrogen atom. So for every element there will be energy levels. For every element, when the electron comes towards the nucleus, its potential energy decreases, and when it moves away from the nucleus, the potential energy will increase. So 0 joule indicates what? There is no force of attraction between the electron and the nucleus. Minus sign indicates what? The electrons are bound to the nucleus. That means there will be a force of attraction between the electron and the nucleus. So this is the energy level of hydrogen atom. Here an electron it's a transition from E2 to E1. It is a de-excitation of an electron. So it is releasing an energy E equal to difference in the energy level, E2 minus E1, and E is equal to hf. H is the Planck's constant and f is the frequency of light emitted. So if the difference in the energy level is more, that means if E2 minus E1 is more, E will be more, and the frequency of emitted light will be more. If the energy levels are close, that means the difference in the energy level is less, then E value will be less, then the frequency emitted will be also less. So more the energy gap, frequency of emission will be more, or wavelength will be less. If less the energy gap, the emitted frequency will be less and the wavelength will be more, because frequency and wavelength are reciprocal. So this is a transition of electron from E2 to E1, and it is emitting an energy E equal to difference in the energy level, and E is equal to hf. F is the frequency of emitted radiation. So for every transition, when an electron comes from higher energy level to lower energy level, that means de-excitation, it will emit corresponding radiation, and there will be a frequency and a wavelength. If the energy gap is more, frequency will be more and wavelength will be less. Next, I am explaining the significance of line emission spectra. Each element produces its own spectrum. From one element to another, the line emission spectrum will be different. It is like a fingerprint. So by seeing a spectrum, we can predict the element. So what is the significance of line emission spectra? From distant stars and distant objects, we are receiving the light and we can produce the spectrum. And we are having the different element spectra, and we can compare the spectrum produced and the spectrum we are having. So by comparing these two, we can predict the element present in the star or the object. So that is the significance of line emission spectra. So that means what? We are receiving the light from the distant stars or object, and we can produce the spectrum of that light ray. And we are already made different spectrum of different elements, and we can compare the spectrum produced by the distant star and the spectrum we are having. So comparing these two, we can find out which element present in the star or the object. That is the significance. The study of spectra is known as spectroscopy. That is the branch of science that deals with the study of spectra. And the instrument that is used to produce the spectra or to study the spectra is known as spectrometer. So that is spectroscopy and spectrometer.